In this tutorial, I'm going to calculate limiting reactant, theoretical mass of the product, and also eventually percent yield. The question is, you have 100 grams of zinc and 100 grams of iodine. Sometimes you have to be able to write simple equations and come up with the product. Zinc is a metal, it's a Zn, plus iodine. Remember, there are 7 diatomic molecules. Iodine is one of them, so it's I2, and it produces zinc iodide. Zinc has only one oxidation number, 2 plus. Iodine is group 7, 1 minus. Eventually, if you have forgotten that, it's an ionic salt, ZnI2. And if you look at the equation, it's balanced. 1 mole of zinc with 1 mole of iodine gives you 1 mole of zinc iodide. I have 100 grams of each species, so I'm going to write 100 grams, 100 grams. First thing to do is I have to convert them to moles. So I go after moles. Moles is mass over molar mass. So in case of zinc, it's 100 grams divided by 65.4 grams per mole. In case of iodine, we still have 100 grams of mass, but iodine is diatomic, so you have 2 atoms of iodine in every molecule. So in case of molar mass, it's 2 times atomic mass of iodine, which is about 127 grams per mole. The first ratio for zinc gives me 1.53 moles of zinc. The second ratio for iodine produces 0.39 moles of iodine. Now you divide by their coefficients and you make a comparison. The smallest of the two is limiting reactant. Coefficients happens to be 1 and 1. So these two numbers divided by 1 is exactly the same. 1.53 is much bigger than 0.39. So this indicates iodine is your limiting reactant. So limiting reactant is iodine. I'll box this. Then let's just move to what is theoretical mass of the product. It's a fancy way just asking what is mass of product, but since it's based on calculations, it's known as theoretical yield. I have to use my limiting reactant, so I start with 0.39 moles of iodine. Then I'm going to use my balanced equation and the ratio to find out moles of product. For every 1 mole of iodine, I have 1 mole of zinc iodide. So I put 1 mole of iodine in the denominator to cancel them out. And I put 1 mole of zinc iodide here. If you stop here, what you find is moles of zinc iodide, which happens to be 0.39. But let's carry one more step. Let's multiply moles by molar mass, and then we have mass. Now remember, molar mass is grams over mole. So 1 mole of zinc iodide, you have 1 zinc and 2 iodine, so it's 65.4 plus 2 times 127 is 319.4 grams per mole. Moles of zinc iodide cancel each other out. Your final answer will have grams of zinc iodide, which is your theoretical yield, and it happens to be 124.6 grams. So we calculate the theoretical yield of our product. The only product we have is zinc iodide. Now let's go to the next slide and look at percent yield. If the actual yield of the reaction is 110.2, what is the percent yield? Now, actual yield is what happens in the laboratory. It's experimental. On a rare occasion and a rare reaction, you might get 100% yield. Usually you have some waste or some reactant that do not react. Percent yield, by definition, is a ratio. It's actual over theoretical times 100. So in this example, we have 110.2 grams, which was actually produced in a laboratory. And what we calculated on the previous slide was 124.6 grams. Now this is zinc iodide, the grams and the identity goes away. Your final answer times 100, is about 88.4% yield. So we have seen limiting reactant, theoretical yield, and percent yield.